this video, we are going to see the procedure of calculating the equivalent resistance of this network across A and D. So first we have to see which components are in parallel, which components are in series. In the first glance, R3 and R4 are going to be in parallel with each other. So if two resistors are in parallel, we use the formula 1 by R equivalent is equal to 1 by R1 plus 1 by R2. So R1 into R2. R1 is here, R3 is like R1, right? So 1200 into 600 by 1200 into 600. That will take value like 400. Okay, so which means we can replace this entire thing with one single resistor whose value is 400 ohms. So now after replacing, again if you see 200 and 400 are in series, so we can add them and we can replace that entire combination with one single resistor whose value is going to be 400 plus 200, that is 600, that is R8. So R8, so I am replacing this entire combination with one resistor whose value is 600 ohms, that is 600. Now after replacing, again I have noticed that 600 and 1800 are in parallel with each other. Now I will apply again the formula to reduce the parallel resistors into a single equivalent resistance. So that is like this: 1800 into 600 by 1800 and 1800 plus 600. The value of that is 450. I am going to replace this entire thing with one single resistor whose value is 450. Okay, so that is R9. So I have replaced this entire thing with one single resistor whose value is 450. Now I have noticed that this 450 after simplification is going to be in series with this 150. So I'll replace this 450 and 150 with one single resistor by adding them. So 450 plus 150 is going to be 600. In place of this two resistors, I'll put one resistor whose value is 600. Now after simplifying, further simplification is also possible. Scope is there. So 600, 600, 300, they are in parallel with each other. So I'll use parallel equivalent formula. So that is 600 into 300 by 600 plus 300, like R1 R2 by R1 plus R2. So that will result one single resistor whose value is 200 ohms. So what I have done here is I have reduced the big circuit which used to look very complicatedly into a single valued resistor whose value is 200 ohms. So we use the series parallel formula in reducing the complex networks into a simple one. So at the beginning it looks very complicated, but when you see it from the point of simplification, which are all possible to be reduced into a single value by using the series parallel formula, you can reduce the complexity of the network into a simple one. So after the completion of this video, I believe the student will be able to understand um, complex. We have come across the simplification procedure of series components and parallel components. So when the voltage gets divided, when the current gets divided, the student will get the clarity. So student can able to calculate the equivalent resistance for a given network after the completion of this video. Thank you.